Hi everyone, today I have the second video in my series on one-edge megaminx OLLs. Before getting into the Algs, I want to mention a few things about the structure of the series. There are 81 total one-edge OLLs, and if we take out the full corner case from the previous video, we have 80 cases over 16 corner orientations. It turns out that each corner orientation has exactly 5 one-edge OLLs, so each video is going to have 5 Algs with each and the video is going to just be about a specific corner orientation. Also, some of the videos will have 10 Algs, as we discussed earlier, for the orientations that should be learned in pairs like soons and anti-soons. My corner orientation order is going to be from a website that I will link in the description, and I think that's all. That's all like the groundwork I need. So with that, the first corner orientation group is the one with 3 corners solved, with the 2 unsolved corners forming a set of headlights. And for this first case, the way I recognize it is that it has this corner orientation and is symmetric. I know it's a little bit different from the usual way to recognize OLLs, but I think it works pretty well because with one-edge OLLs, you don't really have a lot of blocks to work with, and for a lot of the cases, I have to do some kind of weird left-right thing to make sure I'm doing the right Alg. But with a symmetric case, I don't really have to do that, so this one just kind of sticks out to me as a good case. And the Alg for this is a combination of two other megaminx OLLs. The first one is a 6-move T, and then the next one is this fish, which goes like this. These next 4 Algs in this video all have a 1x3 block on the side, and the way I distinguish these two from the next two is that if I consider this kind of like line where the center, with the center and the solved edge, this 1x3 is parallel to the line, and in the other case it's just on the side here, sort of like perpendicular. And then I call this 1x3 an attached 1x3 when it is parallel, and then the other 1x3 would be unattached. So once you have that, the way you tell the difference between these two cases is one is a left case and one is a right case, but I haven't really had very good success with using something like distinguishing between left and right in a solve. So the way I tell the difference between these two cases is that if you start from the center, you can sort of like notice an L here and an L here. One L starts from the outside and it ends at the center, and then the other L starts at the center and ends at the outside. So I'll go with this case first, where you go outside to center. The Alg for this is and the Alg for center to outside is these two cases also have a 1x3 on the side, but if you consider the line below the center and the solved edge, this 1x3 is not parallel to that line, neither is this one. And the way you tell the difference between these two cases is one is a left case and one is a right case. But again, it just hasn't really, I haven't really been able to tell left and right very well in a solve. So the way I do it is I consider this solved 1x3 line, and then these 2 extra corners. And here, if you go down the 1x3 or like up the 1x3 line, you'll sort of form a backwards L. And then if you go along the 1x3 line here, you'll form a forwards L, like this. So for the backwards L case, the Alg is for the forward L case, the Alg is that Alg was also a combination of 2 other megaminx OLLs. Those were the 5 OLLs for this corner orientation. Thank you for watching, and I'll see you in the next video on Monday.